What's up, guys? This topic is called evaluating expressions, and this one should go by pretty quickly. We'll do it two different ways. One where we kind of use the properties of the reals that we talked about before, and then the first way, though, we'll do it as we normally would. And so the idea here is we're adding um, x's and y's and then just regular numbers, right? So we call things like x and y variables, and if it's just a number by itself, it's called a constant. And so when we evaluate something like, let's say, 4x minus 1, and we want to figure out, well, what's the number when x is equal to 1, right? We can replace, because if it's a variable, we can replace it with the 1. But we can't say, like, well, what if 4 is equal to 1? That doesn't make any sense. So numbers we can't replace. Variables are essentially like boxes. We can kind of put what we want in the box or what we're told to put in the box. So if we wanted to evaluate this, all we would essentially do is replace the x with a 1. I like to write it in parentheses so that I can easily see what operation I need to do first with PEMDAS. And so now we have 4 times 1, right? 4 times 1 is 1. Then we bring down the minus 1, and we have one operation left. 4 minus 1 is 3. Okay, so the difference here is we're not evaluating this expression by plugging in like x is equal to 1 and y is equal to 2, though we could do that, right? Um, we could plug in 1 for x, and so we would replace all our x's with 1s, and we would replace all our y's with 2s. And so it would look something like this, right? And then we would do order of operations, and we'd figure out what this number is equal to. But if we didn't want to evaluate the expression that way, we just wanted to simplify it, right? So and simplifying expressions, we're just going to add the like terms together, right? Things that are of the same type. So we want to put the x's with the x's, the y's with the y's, and the regular numbers with the regular numbers. And so, well, we see that here's an x here, here's an x there, there's a y there, and then there's a regular number there. So 2x minus 3x, right? That's negative x. 4y plus 2y, that's 6y. And then we only have one regular number, so it's just minus 7. Now, let's try to do this problem again using the properties of the real numbers that we used in the previous section, that we learned in the previous section. Because what I would argue here is that how are you combining the 2x and the negative 3x if they're not right next to each other, right? We can basically only add stuff that's right next to each other. And so what you need to use from the previous section is this property, which we called the commutative property of addition. So if everything is addition, we can swap the order of things. But this is not true, right? This doesn't work for subtraction. So a minus b is not the same thing as b minus a. So for instance, 4 minus 2 is not the same as 2 minus 4, because this one's a positive 2, right? And this one's a negative 2. So this property will only work if everything's addition. So what we're going to start doing on this one is making everything addition by using the fact that multiplication is division and addition is subtraction. And so what do I mean by that? I'll just quickly go over it again, right? If you want to divide by a whole number 3, this is the same as multiplying by its reciprocal, 1/3, right? And so if you want to if you want to take away a number, right, you want to subtract 2, this is the same thing as adding negative 2. And so we're going to use this ID here to make everything in this expression addition. So this one's already positive, so 2x, that's fine. Well, 4y is positive, it's already a plus. But here we have a subtraction, so what I want to change this to is plus negative 3x. This one's already positive, so that's cool. And then this one I'm also going to change, though it might not come into play in this exact expression. And so now we have everything, right, is essentially has a plus between it. All the um, all the terms in this expression have pluses between it. So now we can make use of this commutative property of addition, and now we can actually switch things around. So this says a plus b. We want to make it say b plus a, so we can easily do that by swapping the places of the 4y and the negative 3x. And now what you'll see is that we have all the like terms together. So now we can actually compute this. 2x minus 3x, that's negative x. We'll bring everything else down. And now we have our y's together too, so we can combine those terms. And since we don't have any regular numbers to add or subtract, well, we can just set this back to how it was. And so, right, we get the same answer that we got up here. And so, am I asking you to do this on every single problem that you work on? Use this like property here? No, but the idea is that like you guys are good enough with addition and subtraction that you guys kind of know how to do this inherently, that you don't have to like describe this all the time. But in the homework there will be questions that ask you to explain how you're doing each step, and so you're gonna kind of do stuff like this. And we'll cut the video here. I'll see you guys in the next one.